Hey, and welcome back to the series where we are making tic-tac-toe games with a twist. In the previous episode we created this Tic-Tac-Toe Ultimate, or maybe some of you know as Super Tic-Tac-Toe, Meta Tic-Tac-Toe, or Tic-Tac-Tic-Tac-Toe-Toe. There are a lot of fun names for this variation, and this variation adds a whole new depth of strategy to the game. But in today's episode I want to focus on our basic tic-tac-toe and then on its most common problem, which is getting a tie or a draw, which is quite easy to obtain by just blocking the opponent's moves. There are some fun variations we can do to encounter this, but let me explain you the one we're gonna create today. In this variation of tic-tac-toe, we are going to encounter the tie or draw problem by making the maximum amount of markers we can play equivalent to the match pattern. So in this example, we will give both X and O just 3 turns, and after both have placed their turns, we will allow them to swipe or move one of their markers to an open neighbor. This way we will have a game which is unable to result in a draw or tie, just because the game field will never be full and both players will always be able to move one of the markers. The game will only end once one of the marker has achieved the match pattern. I haven't found any official name for this type of tic-tac-toe, so for now I will just call it Swipe Tic Tac Toe, but if you know the official naming, please let me know in the comments. Now let's make this work in the code. For this variant I wanted to have a basic tic-tac-toe again. So therefore I discarded everything from the previous episode, so we just have the basic tic-tac-toe and the AI. But since the AI for this tic-tac-toe is gonna be too complex, I will also disable the AI. So let's do that first by removing the code in the game panel. I will remove this code and remove the check if the AI is moving. And this will end us up with a basic tic-tac-toe game where we can play against ourselves. And then what I want to do next is from this match, which is 3, I want this match to be our maximum marker index. So for the markers X and O, I wanted to go maximum of 3, which in this case will be 6 markers. So therefore we can go to the grid, and on the mouse released, we can just quickly check if we do a if marker index is bigger or equal than our main.match times 2, since we have 2 markers, we're just gonna return and see what will happen. And this should leave us like not being able to add any more markers if we have exceeded our maximum. And we can then move this to our isActive here. We're also eventually gonna need this X and Y to check the marker in this check for the if we have exceeded. We're also gonna need this X and Y. We're eventually gonna need this in this check if we have exceeded it. So if you're selecting placement and markers to move, we eventually gonna need which marker. We need to know which marker it is, and that we can eventually do here. And because we eventually still want to loop through all the placements instead of return, I will rename this to break. And this should leave everything working. You can quickly test. So now we cannot place, but we know inside the markers that the maximum has reached. So for now, the first thing we're gonna add is create a selected marker. So I will create a new variable here for the placement, call it selected marker. We're gonna set the default by null. And in the reset, I will also set it to null. So every time we reset, this is at least being resetted as well. And then in the mouse released, if it's active and we have found the marker index, and the marker index has exceeded the maximum of us, we're gonna check if selected marker is equal to null. But also if this marker, so markers from our X and Y, and then the type is equal to our marker index, and then modulo 2, since we want to have it, since this is always going to be 1 or 2, this get type. And if this is the case, this means this selected marker can be set to the marker from this for loop which we have found, which is active, so our mouse is hovering over this. Selected marker equals to the placement. And this is going to mean first click, since our selected marker is null, and then else if selected marker is not equal to null, it means we have our second click. So this is first only gonna be defining what the selected marker is. And in here we can eventually do, if they have a second click, we're gonna move the marker to that position, or we're gonna reset the selected marker since it been or clicked too far, or we clicked again on the same marker. So let's do that as first. So if selected marker equals to placement, it means we pressed again on the same placement on the marker we already selected. So we're gonna reset it. We're gonna toggle it in this case. So here we can say selected marker dot set selected to false. And I will also copy this here, and for this I will set it to true. So here we have the selected marker, and we will set this placement, which we just linked to this selected marker variable, and we're gonna set it to true. And here we'll create a method, and for here I will say this dot selected, this dot selected equals to selected, and I will rename this to selected, and here add a new boolean. Equals to false. And just to make things visible in this render, I will say if selected, then we will draw selected and with the graphics render, and we will create this method as well. And I can actually copy all this and paste it in here. And just for this color, we want to have a special color. I want it to be a bit blue. So let me copy paste it here. This is like a very light blue color, so it really shows up that this placement has been selected before. And then we're going to draw it, and we're going to reset it back to white. So in the next draw, it will not be set to this color blue as also. And we also don't need this code anymore, since we are now going to also check the collision even though a marker is selected. Now back to the grid. So here we've set the selected marker, but we also don't need to forget to set the selected marker to null and return here. And before we can make this work, this will not work because we are still checking the collision for all placements. I can show you quick. I think we are now still not able to move. Oh, well, we can here. We can select it, but we could also still make selections over here, which is not what we want. But we can now select and deselect, but we cannot press here because it will try to find the marker which is not set there. So here it will try to find the type which it should not be able to. So let's fix this, and this we're gonna fix by doing a check here for the collision. Like if it's exceeding the maximum, we're gonna check only if it's X turn, only the axis, and if it's like trying or if it's already selected one, it will only check the selected version and the open cells which are not selected or which have no markers left. Right, I will just edit here and say private boolean check placement and placement, and first I will need the marker, also markers from our placement.getX index and our placement.getY index. And then here we're going to return, well, first if our marker index is bigger or equal than our main.match times 2 again. And if this is the case, we can also check if our selected marker, equals to null, and then or our selected marker equals to this placement. And when it's these cases, if it has been exceeded and it has been the selected marker or it has not been, or it has been the selected marker or not. We're going to return the placement that is marker placed. We will need a new getter for this as well. Here, otherwise, if not placement that is marker placed. And now let's create this and return here marker placed. So this is if we have gonna set this. And also what we're gonna eventually need, because we have now here the is active, but we also will need the set active here. Public void set active. We will eventually need this. Active. And then fade in equals to active. We don't need this now, but since we already have it here, and eventually we will gonna need to reset the active stage from the placements, we will eventually gonna need it there. So now let's see here, I also have an error here. This is boolean, sorry. And in here we will also check if the marker.getType equals to our marker index modulo 2. Now we have to add this here to our check for if the placement is active or not, so the check collision. So if check placement from our placement, if that is true, we're gonna check the collision, since it will now always check the collision since we removed if the marker is placed, that it's not gonna set it to active. We are now gonna define it here by if we exceeded the match, if the placement has a marker placed, and if that marker is the marker we want to try to find. So in case it's X's turn, we want to have the placements where the X's are on. And if it's not the case, then we're gonna say if there is no marker placed, then it's also gonna return it. So let's quickly check. So now we cannot set anything here, but we can, well, only now select the X's. And now we can select the other positions, but we cannot move because we don't have any logic here. So we can now only set it or only toggle it. So now from this point, we're gonna need to define the neighbors from the selected marker actually. So I will do here an if selected marker is not equal to null. We're gonna do I will first define the local variable here, an array list of the placement, and call it neighbors. Neighbors equals to null here, and then in here we will check neighbors equals to checker dot get neighbors from our selected marker. Or let's actually, we're gonna rename that because it's not our selected marker, but our selected placement in this case. Oh well, we can keep it the selected marker, it's actually basically the same. And we're gonna create this method here. And for here, I will first define the result we were gonna need. Equals to new array list placement, and we don't know the size yet. And then just for readability, I will say int x equals to our selected marker dot get x index, and the same for the y. Just because otherwise this will be quite a long thing to type every time. And now we will have two for loops. So I will have the I, and we go to -1, and we go to equal to 1. So this will check one to the left, in the middle, and the one to the right. And we're gonna do this 2 times. So we always also do for the J, which is gonna be the Y checks. And then for here, I will first want to define an index, because we cannot do Y and J, because the placements is not a multidimensional array, but just a list. So it's gonna be from 0 to 8. So we need to have these indexes. And herefore we'll need a new method as well. So we'll get index relative relative to x and y. Oh, not z, but x and y. And then I will do x plus y plus I, and then y plus j. And then if index is bigger or equal than 0, it means we are in the range. And if our x or index is lower than our placement dot size. Oh, placements dot size. If that's the turn, we're gonna say result dot add the placements that get our index. And eventually return this to result. And we can now create this method, and for this we can say x and y, and if x is lower than 0 or y is lower than 0, we're gonna return -1, and otherwise we're gonna return main.rows times y and plus the x. And this is needed because it is possible that we have like -x, -1, but still the y in, for example, the first, then it will still return 3 because it will be, or it will return 2 because it will then be 3 plus -1, which will be 2, which is not what we want because we were trying to access a neighbor which is inaccessible. So now we have this working, we can go to the grid, and we have now here our neighbors. And here in the second click, if the selected marker is equal to the marker, we're going to return here. But here we're going to check if the neighbor that contains our placement. And if this is the case, we have found a match, and we will move the marker. And then if not, no match, toggle the marker again. So when there's no match found, we will say selected marker dot set active, and we will set the active to false. And we will say these set selected. We will also reset it. Set selected to false, and selected marker equals to 0, and then return here. And of course, we also don't need to forget to have the placement. We will set this to false and reset the placement as well. Set active to false. And then in here where we found our match in the neighbor, now let's first define the marker here. The marker equals to markers, and then the selected marker dot get x index, and selected marker dot get y index. And then we're gonna say from our markers, well, again this one, we're gonna set this one to 0. So we like grabbed it out here, and then we're gonna remove it. And then we're gonna say the markers x and y is gonna equals this marker. So we basically gonna move it out from where it was and insert it in where our new marker placement is. And from this point we will say marker.update position. We will add this in a moment too, to this new x and y. And we will set our selected marker. We will set it to false in this case, because it's not gonna be set anymore. And we're also gonna set the set active and selected to false. And we're gonna set it to 0 as well. So in this case, it's only, not set anymore. It's not set anymore because it has no, the marker is moved from it. So the marker is gonna be moved to the new placement. And here we are not gonna set it because it will still remain if it's there, but we will not need it. And for the placement, we will set it to true, because now we have moved this marker to this position, so this placement has to be set to true. The marker index is gonna add up because we have a new move made. So now it's O's turn, so it's not gonna stay X turn. And we will check the win here. We will create this method too, and then we will return because it's not needed to do the whole check again. And this check win I will generate first. This is an easy one because we have a check win in the place marker. So we'll basically copy and paste this code in here and remove this extra line and say here check win as well. And we can also set the move position, and for here we will say this.x equals to x and this.y equals to y. Say here x, here y. And this will then set the position here and we'll set it to the size. Oh, accidentally closed something there. And let's now go and test this. So now if we open this, we're gonna move it. And now it moves, and now it's O's turn. And now it's again X's turn. So now it seems to work already. And we have a little problem because it thinks it's a tie, which is impossible because, well, basically it is a tie because there's no win. But this is not what we wanted because we, trying to add this variant to have no possibility to have a tie or a draw. But this is happening because we still keep the marker index from adding up, and here it will check if it then has exceeded the size and will game end. But because we are now literally adding, or we are now not literally adding up to the marker indexes for how many are placed but whose turn it is, we are not needing this check anymore. So if we run again, we will now not be able to play here again to place the markers, but we will be able to move. And let's see if we can make somewhat a win. And X is 1. So that is already really fun. And gives us a whole new strategy to the games. There are a lot of opportunities now to win. And I think we can also, if we check in the main and we set the rows to 4, we will even be able to move them further than just these 3 rows, which makes it even much harder and much more fun to try to find the winning strategy. For now, one thing I really dislike from this is that the markers are instantly spawning from one point to another. So I want to add a movement to the marker. So instead of here updating position, immediately setting this position, we will create a few new variables here. So I will go up here and I will say private. I'll call it float in this case. Target X and private float target Y. And we also move these 2 floats. And I will add a new, or not add a new, but move the size to here as well. We now have it here locally. So this size, we're gonna move it up here. And d.x is gonna be x times size, and y times size. And then in the beginning, this.target x equals to this.x. And the same for the y. And this means that in the beginning it will not move, it will just spawn it in. But then if you're gonna move it from that point, it will move towards this target, where we will create it in a moment. And then in here we can remove this size checks and cast these x and y to an integer. And now in this update position, I will say this dot target x equals to x times size, and our target y equals to y times size. So now we gonna make this move towards this target if these are set. So in here I will check if x is not equal to our target x, or our y is not equal to our target y. let's say move, move marker. And then with the delta time. And let's create this method here. So in here we will gonna define them. So first I will have a direction. So D or XD for X direction, and int YD are both equal 0 at the start. And here we will check if X is not equal to our target X. We will define XD equals to X is bigger than our target X. And if that's the case, it means we have to move to the left in this case, because the target is on the left and we are on the right because we're bigger. So the direction is going to be -1, and otherwise it's going to be 1, because if it's not bigger, it's on the other side. And we're going to do the same for the Y. So here we'll just rename all the X's to Y's. Y direction. And then here we'll say X plus equals our need to create that too. So I will first here move speed times our XD, so X direction is either going to be left or right because of the direction, times our delta time, and the same for the Y, but then the Y direction. And let's do here a private float move direction, move direction move speed equals, let's say, 10 pixels per time. It's not going to be like this, like a really low number, because this is going to be from 0 to 1. We're now going to be from 100 to 366, for example, or something like similar to that. And then in here we're going to check if our X direction is bigger than 0 and our X is bigger than our target X, or our X direction is smaller than 0 and our X is lower than our target X. This means we have exceeded, either if you go to the left we went too far, or went to the right we went too far to the right, so we have passed our target. We're gonna set X equals to target X, and this way it will lock itself in. So for here it will then not do the X calculations, and here as well. So it will then, the next time it runs here, it will not move, because the X direction is to 0 and move times the X direction 0 is 0. But it is possible that the Y is still needing to move. So let's do this for the Y as well. Rename all the X's to Y. And set here the Y to the target Y. And this way it will also clamp it, otherwise it would most likely stutter a little bit. And well, we can basically see if this will work. And now they are moving instead of instantly going towards the direction. And OS1. And just one more thing I wanted to change to this as well is just the render order. I don't like the grid to be on top of the markers. Let's do this render grid down here. And as I just realized, the game end is here as well on the render grid. So let's move it down here. Otherwise the markers will be drawn on top of this, because we moved it down. And let's run it. And now if we move, it will move over. As you can see here, we can now, well, not move all the way here. We can only move to the position, well, relative to the neighbor. So we can move diagonally, but we cannot move all the way to here. So that was it for this tutorial. As you could see, it was quite easy. It was quite easy to manipulate this basic tic-tac-toe to something which is changing the whole gameplay experience, and basically removing the tie or draw from tic-tac-toe, which is actually like the most annoying thing from it, because otherwise you can only win if the opponent makes a mistake. And well, here it's actually also the opponent needs to make a mistake to win, but it has a whole new strategy, and there's no possible way to tie except from making the same move over and over again, so no one will eventually win. But there is no state in the game possible to have a tie. Maybe if you would really like to have still a tie to it, you can add a maximum move counter. So if both X and O have moved 20 times, for example, the game will tie as well. So we will add a gap to it. But what I really like from this tic-tac-toe variant is that there is only one winner. I really hope you enjoyed this episode. If you did, please consider giving me a like and subscribe. And you can put up the bell notification to get notified for the next episode. But for now, I hope to see you in the next video. Goodbye!